Okay, so here is a demo of my playground to understand bias-variance trade-off for polynomial regression. So when a student enters, he gets an interactive walkthrough explaining how to use this interface. So let's skip it for now and let me give you a walkthrough. First of all, we have a discussion here which explains various things like polynomial regression, what is bias variance and how do you compute it. So what is bias variance trade-off, and all the different plots that we have in this demo, and how do you interpret all these plots. Now let's go to the demo and understand what all things we have over there. So on the left you have parameters that you can tweak to understand the bias variance trade-off. So you have a couple of data sets that you can try on in this demo, and then you can decide the concentration of your sampling. You can have like more amount of data, or probably you can have less amount of data. And also you can alter the amount of noise that you want to have in this demo. Let's keep it here for now. On the other hand, you also have a parameter which decides what degree of polynomial you want to fit in the data. In the middle, we have the scatter plot where blue dots represents all the different points in the data sample, and pink line represents the regression plot. Notice that you have a zoom out option here, which allows us to see the bigger picture and understand what's going on in different parts of the distribution, which were not there in the training data. At the bottom, we have a brief summary which explains all the different plots in the playground and helps us understand how do you interpret all these plots. On the right, we have two curves which demonstrate how the bias variance trade-off changes as you increase the degree of the polynomial. So these curves are generated by repeatedly sampling the distribution and then plotting different regression lines on that distribution. And you have this distribution of errors, and we use this distribution of errors to compute the bias and variance for each degree of the model. So in this box plot, each box represents the distribution characteristics of the residuals, which are computed by subtracting the original predictions and the actual values of the y. So notice as you go towards the right, as the model degree increases, the distribution goes down, which means that the residuals are less and hence the error becomes less, which corresponds to the low bias. But as you go right, the spread, or probably the height of these boxes, also increases, which corresponds that the variance of the model has increased. The bar chart over here corresponds to the actual value of bias and variance for different degrees of the polynomial. So the green bar over here represents the bias of the model, and the purple bar represents the variance of the model. So again, notice that as you go towards the right, when the degree of the model increases, the variance increases and the bias reduces. Similarly, you can see when you go towards the left, the variance decreases and the bias increases. So this curve appropriately represents the bias variance trade-off as we increase the model degree. Now let's quickly see what happens in the case of a linear dataset, where you don't have a lot of options to fit different lines. So you can see that in a linear dataset, you don't have a lot of options, so that's why the bias of the model remains the same. And this is also shown in this box plot because the box plots have the same level inside this curve. So that was all about the demo. You can see that you have a legend over here which explains the meaning of different colors. You have a help button over here which explains which you can click to again go to the walkthrough, and then you have a couple of links over here which you can click to understand like what is polynomial regression and what is bias variance trade-off. Yeah, that's it. Thank you.